All right, let's continue with our exam review, starting here on question number 24. If a triangle has sides with lengths 5, 7, and 10, what is the measure of the largest angle? So first thing we should do here is sketch a diagram of our information. So 5, 7, 10. And we want to know what the measure of the largest angle is. Now you could find every angle that's on the diagram, but hopefully you realize that the largest angle is going to be the one across from the 10, which is this angle here. This is the angle that we need to find. I'm going to call that angle A, label the other sides B and C. And if you look at your oblique triangles foldable, and look at our picture here, notice that we are given side, side, side is the information that we're given, side, side, side. And if you look on your foldable, it indicates there that we should be using the law of cosines. If you open up your foldable for the law of cosines, up on the top flap you should have a formula there to find to find an angle. And the formula looks like this. So if we substitute in the information from our picture, we get cosine of A is equal to 10 squared minus 5 squared minus 7 squared divided by negative 2 times 5 times 7. And if you enter all of that into your calculator, you are going to get a decimal number that is smaller than 1. And hopefully that number does not make sense to you. Remember that whenever we are looking for an angle in our calculator, we must do the inverse. You need to do inverse cosine of whatever number you get when you put this into the calculator. When you do inverse cosine, the answer that the calculator should give you is 111.804 degrees. Now if you're not getting that answer, you need to check and make sure that your calculator is in degree mode and not radians. Let's move on to number 25. Okay, sorry for that break, little technical difficulty there. Number 25, a pirate ship and a rescue boat are 5 nautical miles apart when they spot a stranded sailboat. The angle between each boat and the sailboat is shown below. How far is the rescue boat from the sailboat? And we're given a picture here with that information. So we're looking for how far the rescue boat is from the sailboat, which is this side here. I'm going to call it P since it's across from the pirates. You can call it whatever you want. If you look at the given information that we have in our diagram here, we are given angle, side, angle. And if you consult your foldable for oblique triangles, you'll see that angle, side, angle indicates that we need to be using the law of sines. Now remember, with the law of sines, we must have an angle and the side across from it in order to apply the law of sines. And what I have right here so far, the only side I have is 5. The angle across from 5 we don't know. However, we do know the other 2 angles, and we know that all 3 of these angles must add up to 180. So 35 plus 60 is equal to 95, and 180 minus 95 is 85 degrees. So I know that this angle here is 85. Now I can use the law of sines. And I'm going to say that sine of 85 over 5 is equal to sine of 35 over P. Of course, we're going to use the 35 because that's the angle that's across from the side that we're looking for. In order to solve for P, we're going to cross multiply. P times sine 85 equals 5 times sine 35. And then to get P by itself, of course, divide by sine 85. Again, make sure your calculator is in degree mode. You can put all of this in your calculator, and the answer is 2.879 nautical miles. Let's go on to question 26. In triangle ABC, A is 4.2, C is 5.7, angle B is 76, find B. So let's sketch a picture real quick. I'm going to draw a triangle and just label it ABC. It doesn't matter which order you label it in as long as we put this information on the triangle correctly. Side A is 4.2, so that would be here. Side C is 5.7 here. And angle B is 76 degrees, so that goes in here. If I look at my given information, I have side, angle, side. And if I consult my oblique triangles foldable, side, angle, side indicates that I need to be using the law of cosines. We're looking for side B, which is here. And so the formula that we're going to use from our foldable, B squared equals A squared plus C squared minus 2AC cosine 76 degrees. So if we substitute in these numbers, 4.2 squared plus 5.7 squared minus 2 times 4.2 times 5.7, oh no, I'm going to run out of room, times cosine of 76. Now when you put all of that in your calculator, it's going to give you a number that's too big. But remember, all of this is equal to b squared. You must square root whatever answer you get from this, and when you do that, when you take the square root, you should get b equal to 6.208. Let's move on to 27. Number 27, triangle DEF. D is 13, angle D is 55 degrees, angle E is 70, find F. Alright, so triangle DEF, side D is 13, angle D is 55, angle E is 70. And we want to find side F, which is over here. Our given information, angle, angle, side. If you consult your foldable, that angle, angle, side indicates that we need to use the law of sines. Again, with law of sines, you must have a side and an angle that are across from each other. And here we do have that. We have angle D, we have side D. However, if I want to find side F, I also need angle F. I have to have one of these two pieces of information, and I don't have either one. But I do know both of these angles. And so again, we know that all these angles have to add up to 180. 70 plus 55 is equal to 125. And then 180 minus 125 is 55. So side F is 55. Now, if you remember your geometry, if you notice these two angles are the same, and in geometry we learned that if these two angles are the same, that means that the sides across from them must also be the same, which indicates that side F would be 13. But if you don't remember that, then we need to use the law of sines. So I'm going to set this up. Sine of 55 over 13 is equal to, using the D information, now I'm using sine of angle F, which is also 55 over F. And cross multiply F times sine 55 is equal to 13 times sine 55. Divide both sides by sine 55. And F is equal to, when you put that in your calculator, you're going to get the answer of 13. Let's move on to some area questions. Question 28. Find the area of a triangle ABC where A is 10, B is 15, and angle C is 65. So, again, I always like to have a picture. ABC. Side A is 10, side B is 15, and angle C is 65 degrees. So our given information here is angle, side, angle, side. Now if you look at your foldable on the area formulas, you'll notice that we have two different area formulas. One of them is to be used when we have side, angle, side. The other one is to be used when we have side, side, side. If I use the one for side, angle, side, my formula is going to be 1/2 A times B times sine of angle C. That's the formula that we're going to use here. 1/2 times 10 times 15 times the sine of 65. And when you put that in your calculator, your area is equal to 67.973. Moving on to number 29. Question 29 asks us to find the area of an equilateral triangle with sides of length 12. So we need to remember from geometry, equilateral means that all the sides are the same. 12, 12, 12. It also means that all of the angles are the same. Each of the angles would have to be 60 degrees. So in this instance, you could use either formula, because if we know all the sides and all the angles, we could use either formula that we like. I'm going to use the side, side, side formula. And in order to use that formula, I first have to find the semi-perimeter, which means half of the perimeter. So I'm going to add up all the sides, 12 plus 12 plus 12, and then I'm going to divide by 2 to get the half perimeter or the semi-perimeter. In this case, 12 plus 12 plus 12 is 36, divided by 2 is 18. Now we're ready to substitute into that area formula, which looks like this. S times S minus A times S minus B times S minus C. If I substitute in my values, we found S, the semi-perimeter, to be 18. So 18 times 18 minus 12 times 18 minus 12 times 18 minus 12. Or you could have just put 18 times 6 times 6 times 6. And when we enter all of this into the calculator, you get area equal to 62.354. All right, question number 30. Find the area of the quadrilateral that's pictured below. Now, the area formulas that we have on our foldable only work for triangles, but I can easily make two triangles here by dividing the quadrilateral like that. I don't want to cut the quadrilateral through the angles that we know. Keep those angles there because we need them to find the area of the triangles. If I consider this triangle here on top, notice the given information is side, angle, side. And so I'm going to just label this triangle ABC. Side, angle, side means I want to use the formula that looks like this. Area is equal to 1/2 A times C times sine of angle B. 1/2 12 times 6 times the sine of 100 degrees. And that's all there is to it there. Plug that into your calculator, and it's going to give you an area of 35.453. Now notice in this picture, the other triangle, the other part of our quadrilateral, is exactly the same triangle as the area we just found. And so we can take this area that we found and multiply by 2, and we get a total area of 70.906. Let's move on to vectors. In our first question here, let vector u equal 2i minus 3j, let vector v equal negative 5i plus 3j. Show u plus v and show the resultant vector, and then write the component form of the resultant vector w. Now remember, this is given in ij form. We can rewrite these vectors to look like this, which is sometimes a little bit more convenient when we're graphing. Vector v, negative 5, 3. So I'm just going to pick a starting point over here on the grid. This vector says that I'm going right 2 and down 3. So there's vector u. Now if I'm going to add vector v to that, I need to begin vector v where I'm ending vector u. So vector v begins here, and I'm going to go left 5, 1, 2, 3, 4, 5, and up 3, 1, 2, 3. And so that is vector v. Vector u plus v is the resultant vector here. It's going to start where I started and end where I ended. Vector W starts here where vector U started, ends here where vector V started. Where vector V ended. So we've drawn and shown vector W. We need to write vector W in component form. Vector W would be equal to, from my starting point to my ending point, I've gone left 3, and I have not moved up or down at all, so my vertical component would be 0. Now you can double check your work here by simply adding the components that we already had in our previous vectors. 2 plus -5 is -3. -3 plus 3 gives me 0. And so that is my resultant vector. Now question 32 asks us to calculate the magnitude and the direction of vector W. If you look on your vector foldable, we see that the formula for magnitude of vector W is simply equal to the square root of the horizontal component squared plus the vertical component squared. Basically, it's Pythagorean theorem. Because if this were not a straight horizontal line, these components would form a triangle, and we would just use Pythagorean theorem to find out how long it is. In this case, -3 squared plus 0 squared is going to be equal to the square root of 9, which of course is 3. So my magnitude is 3. Now for direction, we do have a formula there, but since it's just a horizontal line, hopefully we can just look at this and tell that the direction of this vector is 180 degrees because it is moving in the negative x direction, which is 180 degrees. Let's move on to the next vector question. In number 33, we're asked to calculate the magnitude and the standard angle of this vector -12i plus 5j. So let's start with the magnitude. Remember that, actually, let's start with a quick diagram. -12i plus 5j, I could rewrite that as -12,5. And if I were to diagram this vector, it's going to move in the direction of the second quadrant because we're moving left on the x and then up vertically. So the vector would look something, actually not like that. It would be more like this, with horizontal component of 12 and vertical component of 5. To find the magnitude, if you have this diagram, hopefully it's obvious to see that to find how long this vector is, I'm just going to do Pythagorean theorem. Square root of -12 squared plus 5 squared. And when you work that out in your calculator, you're going to get a magnitude that's equal to 13. So magnitude equals 13. Now we need to find the direction of this vector. On our foldable, we have this formula that tangent of the angle is equal to y over x. In this case, tangent of theta is going to be equal to 5 over -12. Now remember, we are looking for an angle here. We are looking for theta. Anytime you're looking for an angle, we need to do an inverse trig function. Theta is going to be equal to the inverse tangent of what we wrote here, 5 over -12. And if you put that in your calculator, and if your calculator is in degree mode, you should get that the angle is -22.619. But at this point, we don't need to write that down as our answer. We need to go back and look at our diagram and make sure that this makes sense. Well, if I look at this angle that's in my diagram, I notice that this is not a -22 degree angle. If I draw an XY axis here, -22 degrees would be somewhere down here in the fourth quadrant. But I need a quadrant 2 angle. This angle right here would be 22.619, which means this angle here is also 22.619. What we have here is a reference angle, and it's in quadrant 2. In order to find the direction of this vector that I'm actually looking for, we're going to do 180 minus 22.69. And when I subtract this value from 180, that gives me the theta that I'm looking for. In this case, our angle, our direction, is equal to 157.380. All right, finally, question number 34. I'm going to go ahead and move up the paper so I have a little more space for this one. On question 34, I made one small change here. Change this word to west instead of east. So we have a plane flying 330 miles per hour at a bearing of 120. Wind is blowing in a southwest direction at 20 miles per hour. Find the resultant velocity and bearing of the plane. Remember that whenever we're measuring bearing, it's from north in a clockwise direction. So here's my north reference. This 120 degrees is measured from north, and it would be about like that. 120 degrees. This is 330 miles per hour. Now the wind vector, we need to add it to this vector, so we're going to draw it from the end of this vector. Again, I'm going to put my north reference. From here, the wind is blowing southwest at 20 miles per hour. So southwest would be right in the middle of quadrant 3, right here, 20 miles per hour. The resulting vector, what the plane is actually going to do then, is fly in this direction. And so that is this is the vector that we need to find. Well, I have two sides, 330 and 20. If I had an angle in this triangle, then I would be able to use law of cosine. Specifically, I need to know what this angle is right here. If this angle here is 120 from north to the plane's vector, that's 120. Then this angle down here from south up to that same vector, that angle is also 120. This little angle right here, since the wind vector was blowing directly southwest, this vector goes right in the middle of quadrant 3, which means this angle has to be 45 degrees. So remember, the angle from south up to the plane vector is 120, and this little angle is 45. And if I do 120 minus 45, it gives me 75 degrees, which would be the measure of the angle that's in the triangle formed by all the vectors. Now the information that I have, side angle side, allows me to use the law of cosines. So I'm going to substitute into the law of cosines. V squared is going to be equal to 330 squared plus 20 squared minus 2 times 330 times 20 times cosine of 75 degrees. And if you put all of that into your calculator, remembering to take the square root because that's going to be a large number, you're going to get a resultant velocity of 325.398 miles per hour. Now the second question is, what's the new bearing of our resultant vector? What is its angle? Well, I know that most of the angle is 120, but I need to know this tiny little angle here that's a result of the wind blowing the plane off its initial path. We need to find that small angle, which we can do because we have two sides and an angle in this in our drawing here. I'm going to use the law of cosines angle formula, and I'll just call this angle A. Cosine of angle A is going to be equal to the side across from it squared, 20 squared, minus 330 squared, minus the V side, which we just found to be 325.398. 325.398 squared, divided by negative 2 times 330 times 325.398. If you put all of that into your calculator, you are going to get a decimal number less than 1, But remember, we are looking for an angle, and anytime you're looking for an angle, we must do the inverse. Inverse cosine of whatever you get from all of this in your calculator. And when you put that in, it should give you that angle A is equal to 3.403 degrees. Now this is not our bearing, that's just the angle that's right here inside the triangle. This angle right here is the 3.4. We need to add this to the 120 that we already had. That gives us a bearing of 123.403 degrees. All right, final section, polar graphing. Question 35, simply asks us to graph a polar point on the grid, -3, 4 pi over 3. I always like to locate the angle, do that second coordinate first and locate the angle. So I'm going to go around the unit circle here to, here's 4 pi over 3. So this is the angle that I'm looking at. Now my first coordinate, my radius coordinate, is a negative. It's a -3. And so what that means is that instead of being in this quadrant on 4 pi over 3, I'm going to graph in the opposite quadrant. And I'm going to count the circles, 1, 2, 3. And so this would be my point P, -3, 4 pi over 3. Now for question 36, I'm going to go ahead and stay on this part of the graph so that we can look at our diagram here. It asks us to write the coordinates of this point in two other ways. There's lots of ways that you could do it. There's lots of right answers to this question. One would be to just keep that radius positive. If I change it to a positive radius of 3, then I need to use a first quadrant angle, and in this case that angle would be pi over 3. So that's one version that we could use. We could do a positive radius and a negative angle. So if I keep the positive radius of 3 but consider the negative angle, which starts here and goes all the way around to there, well, that would be 1/3, 2/3, 3/3, 4/3, 5/3. This would be -5 pi over 3. And so that would be another acceptable answer. I'll give one more. You only need to give two answers. I'm going to give one more. What if we did a negative radius and a negative angle? So if I do a negative radius, if I'm going to end up in quadrant 1, that means that my angle needs to be in quadrant 3. So that's this 4 pi over 3 angle again. If I start here and go in a negative direction to get to that angle, then that's going to be -2/3. This way is 4/3. This way would have to be 2/3 because it's got to add up to 6. So -2 pi over 3 would also be an acceptable answer. Again, these are all answers for question number 36. All right, so we've answered 36. Let's move to 37. It asks us to write the polar coordinates, convert the polar coordinates of point P to rectangular coordinates. So point P was -3, 4 pi over 3. If you're using your polar coordinate foldable, you can see that to convert to rectangular coordinates, that means I want an x and a y. X is equal to r times cosine theta, and y is equal to r times sine theta. So x is going to be equal to -3 times cosine of 4 pi over 3, and y is going to be equal to -3 times sine of 4 pi over 3. And there's two ways that you could give me these answers. If you just get these values off the unit circle, this is -3 times 1/2, which would be, -3 times -1/2, which would be 3/2. And this equals -3 times -square root of 3 over 2, which is simply 3 square root of 3 over 2. So if you would like to give me answers in that form, 3/2, 3 square root of 3 over 2 is certainly acceptable. if you put it in your calculator, these formulas right here, then we're going to get 1.5 and 2.598. So I'll put an or there. Either one of those answers is acceptable. Finally, question number 38, just asking you to sketch the graph of 4 cosine 5 theta on the polar grid. And you can use your calculator to get this graph. What I'm looking for is if you can graph it appropriately on this polar grid based on what you're seeing on the calculator. One of the keys to this particular equation is this 4 here, and that means that this graph is going to graph like a flower, some petals. Each of the petals, hold on, I'm going to pause for announcements. Okay, announcements are over. I'm back. Again, it's going to be a flower. It has 5 petals. Each of those petals should go out to a radius of 4. You'll notice that the first petal is kind of centered on the cosine axis, and so I'm going to count out on this axis 1, 2, 3, 4. So 1 petal should go out to that point. Since there are 5 petals, they're going to be evenly spaced around the circle. If I do 360 divided by 5, that is equal to 72 degrees, which means I should have roughly 72 degrees between each of the petals. So my second petal is going to be about here. 72 degrees later would put me at 144, which is about here. 72 degrees after that would put me at 216. And about 72 degrees after that would be right here. I'm afraid to say where it is because I can't do the math in my head right now. So you've got a calculator, you could add that up. That's where the petals should be. And the graph is going to look something like this. Not like that. Let me try again. These petals should actually be a little more rounded out on the end. I'm having a hard time doing that on the Promethean board, but something like that is what our graph should look like. And that is the end of your exam review.